And welcome to our speaker for today's PIBBSS speaker series. This is Rio Popper. She works at the Global Priorities Institute in Oxford, and she'll be talking about Karl Popper and his epistemology and how his philosophical views are relevant to AI, AGI, and AI alignment. So without further ado, Rio, take it away.
I'm going to be talking about the implications of Karl Popper's thought for AI. I think broadly the talk has two parts. First, I'm going to talk for a while about those parts of Popper's thought that are relevant to AI. In the second part of the talk, I'm going to draw out the implications of those ideas from the first part to AI more specifically. So Karl Popper was one of the most, if not the most, influential philosophers of science in the last century. He was also influential in many other parts of philosophy, including political philosophy, epistemology, and the philosophy of history. I think also that Popper is one of the most commonly misinterpreted philosophers. So in this initial half of the talk, I'm going to first discuss Popper's most important ideas in epistemology, along with the context in which he created those ideas or had those ideas, because I think they're well understood with respect to that context, although of course I think they also have relevance outside of it, independent of the context. After that, I'm going to discuss Popper's rejection of inductive reasoning and his method of conjecture and refutation. And finally, I'll introduce the notion of a universal mind, specifically in Popper's philosophy. Then, of course, we'll move on to the second half of the talk, where we discuss AI more explicitly. Popper was born in 1902 to an assimilated Jewish family in Vienna, in what was then Austria-Hungary. His father was a successful lawyer, his mother was a pianist, and his uncle, Joseph Popper Lynkeus, was himself a philosopher. In 1919, so he was 16, 17, Popper joined the Association of Socialist School Students and was, for a time of around 2 or 3 months, a devoted Marxist. This was brought to a rather abrupt end in the early summer of that year, so quite quickly, when Popper witnessed a violent sort of street battle between the Marxists and the police, where several Marxists were shot and killed. This had a lasting influence on Popper, both on his own politics and on his broader philosophical thought. To see why, recall that Marxist theory, as then understood, required that people increase or exacerbate the class struggle as to hasten the overall proletarian revolution. That would cause harm, the theory readily admitted, but less harm than capitalism was already causing. So in short, Popper felt himself an adherent of a theory that demanded he brought about more violence of the kind he was then witnessing for the sake of some distant future end predicted by that theory. This is part of what many Marxists claimed was science. To be specific, scientific socialism. And so Popper was forever turned against such theories, which required some group to make their society sacrifice for a predicted distant reward. Of course, many theories do this in a non-problematic way. Popper was not, for example, opposed to spending money from taxes on investing in education for the sake of some, an educated population in the future. But here the sacrifices are not nearly as large as violent revolution, and the future goal is more proximate and less reliant on unproven theory. I'm going to return to these points about Popper's views on theory and dogma later in this lecture. But for now, it's important to note that at the time, Marxism professed to be a science. Reacting to Marxism's claim to be a science influenced a lot of Popper's later work in the philosophy of science. Around this time, Popper also encountered the psychoanalytic theories of Freud and Adler. His parents were close friends of Freud's sister, Rosa Graf, and in the early 1920s, Popper worked briefly in one of Adler's psychoanalytic clinics for children. Around the same time, he attended a lecture given by Einstein on relativity theory. This lecture, in conjunction with Marx, Freud, and Adler, struck Popper very much. He noticed that Einstein's theory was highly risky in that it made testable predictions that differed from the predictions made by older theories, crucially Newtonian physics, and that, if false, would have falsified the theory. Marx, Adler, and Freud, in contrast, didn't make such predictions. Crucially, those theories were unfalsifiable. Here we see Popper's thinking on the demarcation problem. On the problem about delineating what is science, such as biology and chemistry, and what is not science, such as logic or psychoanalysis. The difference is whether the theory is falsifiable. That is, whether or not it puts forward predictions which, if false, would prove the entire theory or part of it also false. Popper's thought here is a departure from other previous work on the demarcation problem. Bacon and Newton, so Francis Bacon, Isaac Newton, for example, took observations rather than theories as primary. Theories were to be inductively inferred from these initial observations. Popper found this unsatisfactory, primarily because of the famous problem of induction, taken from the work of David Hume. Induction, of course, is the type of reasoning that allows us to move from particulars to universals. For example, this piece of bread is edible to all similar future pieces of bread will be likewise edible. The problem of induction is roughly formulated as follows, and I think it's worth going through this in a little bit of detail, even though it's a bit aside, it's Hume's work, not Popper's, but I think it's still worth going through because Popper's philosophy isn't so much reacting against this, or reacting to this problem. So Hume begins by noting that there are two types of arguments we can make. One type proves its conclusions so definitively that to deny them would be a sort of contradiction, as in a triangle has three sides and its angles add to 180 degrees. And the other type of argument deals with probabilities rather than certainties. This is known as Hume's fork. So the difference between these two types of arguments is Hume's fork, like the branch between these two. Now Hume points out that our inference that the next instance of bread will be edible relies on an assumption that nature is uniform, or at least nearly so, meaning that the future will resemble the past. This is what Hume calls the uniformity principle. Without this principle, our inference wouldn't make sense. But here's where Hume introduces a dilemma. First, if we try to prove the uniformity principle with an argument that provides absolute certainty, so the first type of argument, we find that this doesn't work because denying that the future will resemble the past is at least not a contradiction. It's entirely conceivable, at least, that things might change. So there's no definitive proof for the uniformity principle. On the other hand, if we try to argue that the uniformity principle is probably true, so the second branch of the fork, the second type of argument, we run into another problem. Any argument for the principle would have to assume the very thing it's trying to prove, that the future will be like the past. And that creates a circular argument. Many people have responded to Hume's challenge to induction, and some of these rebuttals seem, to me at least, prima facie compelling. For example, Thomas Bayes' response, or work at least, which some suggest might have been formulated as a response to Hume's work. But I want to sidestep those rebuttals because Popper did not accept any of them. He instead accepted Hume's challenge to induction. So let's return to falsifiability. Note that it requires no induction. Theories come from somewhere, make their predictions, and are deductively disproven or corroborated if the predictions are false. So they're disproven deductively if the predictions are false. it is impossible to prove a universal, all pieces of bread similar to this one are edible. But it is at least logically quite straightforward to disprove one by showing one piece of bread to be inedible. So Popper's answer to the demarcation problem also allows science to avoid using induction. But you might still be confused, even if theories, once advanced, can be falsified. Those theories must come from somewhere. Might that be from induction? Popper, like Einstein, actually, doesn't think there's a standard process for generating theories. To put it a little bit ungenerously, he draws this sort of black box around the theory generating process. Only after theories are released from this sort of black box does the practice become that of straightforward science. But Popper thought that black box to be quite small, like very small. He took all observations, in fact, to be inherently theory-laden, whereas Newton and Bacon take there to be theory-free observations from which we can then draw theories. Popper argues that all observations are selective and one cannot have a theory-free observation. So even as we first puzzle over what seems a random thing which we just observed, we are, in that puzzling, ourselves engaged in internally falsifying some kind of theory or, proto-theory, although Popper would just think of it as a standard theory. Popper thinks it's not just humans that do this. The kind of activity which Popper calls problem solving, so falsifying, conjecture and refutation, is a part of very much of the world. Popper crucially sees evolution as an instantiation of such a system. Evolution can be thought of as a series of conjectures at what kind of individual will survive to reproduce, and refutations by the falsification of the idea that such and such an individual will survive to reproduce. As an aside, I think Popper importantly misunderstands various bits of evolution, but I don't think that matters very much because it's easy to reformulate Popper's arguments to avoid these errors, and it doesn't change the overall takeaway. So we can see in the discussion of evolution the way that Popper thinks of the theory-generating process as analogous to mutations. That is, he sees theories as pretty much random alterations which only over time lead to truth by virtue of the fact that we select for better and better theories by critically refuting them. Others, probably the most notable of which is Thomas Kuhn, have critiqued Popper for not highlighting exactly what causes theories to be generated, which, at least in Kuhn's case, involves creativity and some sort of paradigm shift. Popper's emphasis on the universality of conjecture and refutation helps us highlight his broader view that progress, whether by biological evolution or say, scientific intellectual progress, or I suppose positive social or moral change, occurs not through the accumulation of positive evidence, but through the elimination of error. For Popper, this process was not just a methodological guideline, but a claim about the structure of reality, I think. So the world is such that it allows for the constant generation and testing of new ideas, taking ideas here as a broad term, including classic scientific ideas, but also ideas qua organisms or ideas qua species or ideas qua social systems, etc. Sorry. I think it's worth pausing here to briefly mention something that might seem at first unrelated, but is actually quite relevant. So think about the nature of computation. All modern computers are so-called universal computers, or more often called universal Turing machines in computer science. in that they can perform the basic operations required of a universal computer, universal turing machine, reading, writing, and processing data according to a set of instructions, such as those encoded in an algorithm. Other much more primitive computers were also universal computers, and so too will be the most advanced computers. All these computers can perform the same computations, borrowing constraints of time and memory. That means, of course, that setting aside time and memory, any computer that is complex enough to do almost anything remotely interesting or useful is also a universal computer and can do the same kinds of computations as the most advanced computer. All computations can be written to be computed by all these universal computers, no matter how drastically different they are. Popper thinks something similar is true of minds. Just as there are basic operations which, if present, makes a computer of a class of universal computers, all of which can perform the same computation, so too are there a set of basic operations of reasoning that, if present, make something a universal mind. These operations are conjecture and refutation, so generating conjecture and constructively refuting it. Since all reasoning, to Popper, is conducted with these operations, any reasoner could, at least in theory, reason through the same problem as any other reasoner. And a person is a universal mind, and subject to those important constraints of time and memory, it would be able to think through the same line of thought as an arbitrarily powerful mind of any other kind. So far, I've told you broad strokes of Popper's thought. Now I want to talk about the implications of those thoughts for how we should think about AGI. Before I do that, I should emphasize again that Karl Popper, for some reason, seems to me to be one of the most misunderstood philosophers. This might be because he addressed his philosophy often to non-philosophers, so that his philosophy of science is often used by scientists as well as by philosophers of science, and his political philosophy is often evoked by people commenting on current affairs as well as by political philosophers. It might also be because his ideas have a first gloss that can deceptively seem quite simple. Whatever the reason, I constantly find Popper's ideas used in the oddest ways, and sometimes, I suppose, inverted. So as I begin to apply them, maybe wrongly myself, note that you might go away and read Popper yourself and come to totally different conclusions and think I'm wrong. So now I'm going to make 3 points. First, I'm going to sketch a particular one of David Deutsch's views. I'm sorry, I lost my thought. Give me a second. I'm going to sketch a particular one of David Deutsch's views and talk about why I think it's importantly wrong. Then I'm going to discuss what I think Popper would have thought of AGI. And finally, I'm going to say what I think Popper would have thought about alignment more specifically. So probably the most influential person to apply Popperian thought to thinking about AI is David Deutsch, who, pretty much unrelated to this, I think, was one of the main people to start the field of quantum computing. Deutsch reads Popper's idea about universal minds to imply that humans will, at least in theory, be able to reason through the same thoughts as any AGI, and so AGI will prove much less of a threat than standard alignment views would suggest. That is, subject to constraints of time memory, AGI will be understandable to us. I think this misses important points, but I'll come back to that in a second, once I say one more thing about Deutsch's view. So another aspect of Deutsch's thought relates to the necessary freedom that a universal mind must have. It must be able to both generate conjectures and refute those conjectures. we can think of trying to generate a conjecture, let's say as an example, how to generate a conjecture about how to explain some particular phenomenon or something, as a search problem in some idea space. But the criterion of accepting a result is itself a criterion in that same idea space. And the criterion for accepting that criterion is again a search problem in the same idea space, and so on. To be able to generate and refute conjectures, a mind must be able to refute and generate conjectures on any one of those many levels, though of course not all at once. It's worth noting that Popper himself was careful to note that while conjecture and refutation happens on every level, it cannot happen simultaneously on every level. Deutsch takes this as an argument that to create a universal mind, the whole of idea space must, at least in theory, be open to that mind. It must not be the case that they are stopped from generating conjectures of a certain sort on any level. Although, of course, you could, so Deutsch would say you can't screen off some piece of idea space. I think this is true insofar as you must have a universal mind, and this is like a technical sort of definition, but it seems a bit like you could just get an edge case of a non-universal mind, and it's not obvious to me how this would actually matter. This point would matter in sort of the way the mind operates in practice, though it might, obviously depending on what you're screening off. So why do I overall think Deutsch's view are less than compelling? I think broadly for two reasons. First, even assuming Deutsch is right and AGIs are at least in theory performing the same kinds of computations as humans, it could be the case that AI conjecture and refutation are nevertheless incomprehensible to us because they say reason in some other language that's like, I don't know, cryptographically encoded or something. So even if a human and a potential AGI would both be universal minds, that doesn't imply that in practice, they could reason through the same way as each other. Similarly, Deutsch assumes that hardware improvements in human thinking would allow us to overcome the differences in time and memory between different kinds of universal minds, in this case, between humans and AGI. This is a big assumption, and it could be right. For example, if we're helped by other AIs to keep up, but it does not seem obvious. Separately, let's say we have some AI that's not a universal mind because it can't properly conjecture and refute on some level or something like this, or at all. I don't think this implies that it wouldn't still be powerful. It's quite possible that an AI could still solve a directed kind of problem without being at all general, and that solving those problems would still be worrying, for example, in cases of misuse or goal misspecification. So saying that some AI is or isn't a universal mind might just be a theoretical question of like no real import.
Mm-hmm.
Sorry. So now I want to talk about what Popper would think of AGI. I think in broad terms, he thinks that generating conjectures and constructively refuting them is relevant for building AGI. And I think he'd think we haven't seen all that much evidence of AIs doing either of these things yet. I'm going to first talk about generating conjectures, and then I'm going to talk about refuting them. So I'll start with generating. In general, in Popper's philosophy, there's this black box drawn around how we generate conjectures, as I said before. And that black box seems important. So must all of idea space be open? How do things learn to generate? This problem parallels one in universal computing. So namely that in order for a computer to do a computation, it has to be told what computation to do. A Turing machine must be sort of told what problem to solve before it can do much. So in order for a mind to refute a conjecture, it must first creatively generate some conjecture. That, Popper's philosophy implies, is the gap in our understanding that makes building a universal mind still out of reach. It's unclear to me whether we really need to understand this question well, or how to do this well in theory, before we stumble into building the infrastructure to do that. For example, one of the best ways to learn how to generate problems that you might want to solve on a broad scale is to be first given a broad problem and have to practice generating problems by generating the sub-problems to that bigger problem. And that's basically what we do to AIs a lot right now. So we might be teaching AIs to generate conjectures just fine in the relevant sense by giving them scope problems where they themselves break them down into sub-problems. And maybe one of the main ways of generating good conjectures is through induction. That is certainly compatible with Popper's philosophy, so long as it's followed by refutation, of course, so long as that's within the black box. And AI systems are, of course, well trained for induction. So what it is to creatively generate a conjecture is a philosophically interesting question, but it's unclear to me whether we actually have to solve it philosophically before we solve it, or at least before we give it one solution in practice, though we might. And some people would argue that we do have to solve it philosophically, or at least that solving it in practice would imply some sort of solving it philosophically as well. So that's, I think, the piece to do with generating conjectures. So I'm going to talk now about constructive refutation. So I think Popper would ask how we can instill the ability to constructively refute a given conjecture. And I think this is also non-trivial. Popper's philosophy is opposed to much of the ML paradigm, which rests so strongly on induction. ML systems are good at induction, even induction across different contexts. But it seems that at least LLMs for now are much worse at deduction across different contexts, either between two contexts in training or between one context in training and one at inference. Because Popperian reasoning rests on multi-step deductive falsifications, this is also, at least according to Popperian philosophy, quite important for building AGI. So far I've discussed applications of Popper's method of conjecture and refutation. But just before I end, I want to make a very, very separate point. Popper also has thoughts about theories and about theorizing itself, which I alluded to earlier, and which I think can tell us something about what he might think of alignment. I think Popper would be very wary of intense theorizing about future systems and changing our behavior because of those future theorized risks. I think to change the trajectory of AI is obviously has serious consequences. So AI has the potential to very soon dramatically improve our economy. And that alone has hugely beneficial impacts for millions or billions of people. And to delay or stop that improvement at least subordinates the concerns of those people. Risks from future systems are sometimes obvious and don't need theorizing. So demos type work, so stuff we can see there is particularly, I think, useful to investigate. I think Popper would agree with that. But some risks require many steps of logic, and I think Popper would be wary of the kinds of intellectuals who theorize too far and forgets the proximate and more certain effects of what that theory implies they ought to try to do. And I think this criticism applies to a lot of different parts of alignment, though obviously not all of it. I think all of sort of these points from Popper's philosophy are a useful framework for different, for looking at different parts of AGI. And I certainly think the framework is wrong in many places, but I hope it maybe provides a marginal corrective to some of your thinking in places. Thank you.
Yeah, thank you very much. Right, we're going to turn to questions now. So I'm going to give some priority to people in the room, but also if you have a question and you're in the Zoom call, please do raise your hand. We can already see one hand there. Let's start with Matthias in the room.
Thanks for the talk. So you said that Popper believes that it's more accurate to view science not as accumulation of evidence that is our certainty of some hypothesis over others, but rather than okay, we saw such evidence that this particular theory, like conjecture, should be refuted. But why does he think that? Because it seems to me like a kind of flattering. It could be both, depending on specific circumstances. It could be both in some combination. Why does he think that it's not accurate to say that it's about accumulation of evidence as some proponent of like a Bayesian view of science, let's say?
So the question,
If you can repeat it, if you do it, repeat it.
so the question is something like, you can think of science as Bacon and Newton do, as sort of this taking observations primary, or you could take it as Popper does, as theory is primary and sort of influences observation. Why does Popper view it as so strictly theory laden in this way? Isn't it sort of rhetoric-y? Couldn't it be both?
The conjecture, I'm not correct. I'm not claiming that observations are not theory laden. Yes, sure, but I don't think this is like central here.
Interesting. I think that at least classically, I think a lot of people say, in order for observations to be primary, they must not be theory related. You can come up with another version where it's like observation and theory sort of go back and forth, maybe. I think that the reason Popper wants to construct it like this is because it allows him to avoid having to use induction, and he thinks induction is ill-founded. So I don't think he's trying to say, I don't think he's trying to use rhetoric. I think he's trying to avoid making science rely on induction.
Okay.
We have a question from TJ. Dushan, can you make the call available to? Yes, lovely.
There we go. Hello. Yeah. Thanks for the talk. I think so I think I want to like double click on the whole the historicism aspect in Popper and in the idea that I think that there is this whole thing that maybe like Popper would have seen this whole idea or this whole manner of speculative reasoning that often goes on in AGI, that we are trying to like speculate on the properties of future agents, and then we are trying to like work or steer our research in response to that. And therefore I would like one could imagine that Popper would have the same sorts of complaints about historicism and self-fulfilling character in those as he had for Marxism, for example. There is like one small citation, I think, in Popper's last book, where I think like he does backtrack a little bit, and I've been always curious. He does say that, oh, like I used to have this issue with reflexivity, but it seems like even biology cannot fully like make progress without like admitting reflexivity. He makes like a sort of like an offhanded remark in one of his like last books. And I've always been like curious what he was thinking at that point. But there is a sense in which I think there's something about whether AGI is even a scientific discipline or not that makes like the application of like the Popperian view not necessarily at the level of like whether AIs can do Popperian science or not. I'm operating at the meta level of like whether our own like thinking about AGI is scientific reasoning or not. Because it seems like Popper has mostly been interested in the delineation problem. And so he delineates what is science from what is not science, but then he doesn't necessarily say much about what the right sorts of epistemology should be for things that are not science. And so, for example, it would not be clear what would the Popperian epistemology in design and engineering would be, because you do have to like speculate about a lot of different things, so on and so forth. And so far as it seems like his debates with like some of the people went, like he did not want to like strongly bind them by like theoretical constraints or something. And a related thing is like something that comes up in Popper's debate with the Frankfurt School. So this is something that happens in the late in his life, I think 60s or something, with Marcuse and Habermas, where this is called the positivism dispute. I don't remember the German term for it, where it is not exactly clear because Popper tries to delineate social sciences as not sciences, like sociology as not sciences because of the intrinsic reflexive nature, reflexive character there. He does think that some things are empirically testable, and insofar as sociology can, the falsifiable parts of sociology can be social science, but a lot of other things social theory cannot be. But a lot of people actually disagree because like the Frankfurt School argues that actually like there is a role of critical reasoning even in social theory. And either by rejecting this thing, like Popper is trying to protect something like value-free science, which the Frankfurt School would argue there is no such thing as value, like all reasoning, at least like all social sciences are always value-laden. And therefore, there is no way in which you can escape reflexivity from value. And yeah, like so you cannot escape reflexivity from value, and therefore the question is on how to think about critical rationality or critical reasoning in the context of this value ladenness. And I think this does matter in what we think about AGI, because insofar as one might say that an agentic AGI is this like historicist end of history thing that Popper would like criticize for historicist reasons, we do need to like have a better understanding of how to still be able to do critical rationality insofar as we have to contend with the value ladenness of our reasoning about the future. Did that make sense?
Yeah, that makes sense. So just to pick out a couple of things that I want to say. So I think one thing that Popper would say is that when we have some sort of theory, I think I mentioned this a little bit in the talk, we also have, criteria for accepting the axioms of that theory or the sort of presuppositions of that theory. And those themselves are often value-laden, even in the natural sciences. So some things we accept because of scientific consensus, things like this. And that is a very value-laden thing. Like the nature of scientific consensus is itself value-laden. I think Popper would say, just like observations are value-laden sort of the whole way down, I think that because we have this infinite regressive or infinite layering of different levels of the sort of criteria for success on the previous level, or was it criteria for falsification, I should say, on the previous level, that this allows us to talk about things in a more objective way, while retaining the sort of notion of being value-laden, because you can question them on any of the different levels. You can question the different values on different levels. I think that applies to sort of the sciences and much of the social sciences. I think Popper does not dismiss the value of sort of non-falsifiable work. So he's pretty careful, I think, throughout to mention that, while he calls it pseudoscience, he doesn't dismiss that pseudoscience can be important and can lead to sort of positive outcomes. I think Popper's sort of quibble, I guess, with lots of pseudoscience, as it were, and I'm not claiming that all of alignment is all pseudoscience, but let's say the part that is, or something like this, the part that's over theorized, is when it requires like sharp sacrifices to follow the predictions or what the requirements of that theory. So I think he would think it was great to think about things so long as it didn't require like a pretty severe sacrifice. And I think my claim is specifically with alignment that one, it might be critiqued in the way you mentioned, but two, that it requires a relatively serious sacrifice. And that's what makes it sort of open to this criticism, whereas other sort of types of social theory, which don't ask the same sacrifices of a society, I think, are less open to that criticism.
Yeah.
So yeah, if I can have a follow-up, I'll defer that to Clem, who is chairing the session, I guess. Can I have a follow-up?
Sure. Can you make it a bit briefer?
Yeah, okay. So I think like it seems to me that Popper, like I think like it's hard to notice whether it's just a semantic dispute, whether Popper just wants to call something science and other things not science, or whether it's a normative dispute. Whether so like when the critique is made that alignment is pseudoscience in the sense that it's demanding sacrifice, is it just like a semantic dispute? Okay, like I don't want to call it science, but whether it should be done or not, like it's not making any normative claims or something like it, or whether it's also a normative like critique. Is it also like saying, oh, like because it's a pseudoscience, therefore it has some prescriptive implications or not? Because if it doesn't, then like maybe it's just a semantic dispute. And okay, like sure, alignment is not a science, but does it change it? Like, should we change any of the things we are doing?
I guess I should say, I do think lots of alignment is more scientific, right? I'm not saying it's not a science, I'm saying pop that, just like in lots of
Yeah. Yeah.
I do think it's a normative dispute, not a semantic dispute. I think you could say that there's a semantic dispute and then layered on top of that is a normative dispute. So we could say you could dismiss the normative aspect and say, for some reason, you think that pseudoscience and science should be treated identically, and we can still have a semantic dispute so that, they're somewhat separable. But I think in this case, the normative is layered on top of the semantic. So it's not just a semantic dispute.
Mhm.
Cool. Any other questions, either from anyone in the room or any of the attendees? I guess I have a question which is more on this thing of universal minds. So very briefly, you suggested that there's this kind of two things going on. One is the kind of operations that an AI might do. And then the second being this like meta thing of the kind of things that we might have, the ways we might think about science of AI. And it seems interesting to me that like Popper's thought kind of has implications in both realms. And yeah, I wonder if there's like this particular thing where you mentioned this possibility of, I think you briefly mentioned the possibility of like AI being used for oversight of other AIs, but that there might be some sense in which, like, insofar as minds are generally understandable, other AIs might be used for that understanding. I wonder if there's this weird sense in which that requires science of AI to follow the Popperian structure. So is it possible that the only kind of AIs that are going to be suitable for helping us understand AIs need themselves to be, for example, good at generating falsifiable conclusions or doing deductive reasoning? Or do you think that the kind of AI that can help us understand AI can look kind of different and doesn't need to have this parent structure?
I think that, at least in theory, it does not have to have this Popperian structure. You could argue that it would do better if it did. I'm not sure that's true. It could be true depending on like the contingent factors of, like, I think a lot of this depends on contingent factors of what models we're talking about, like what AGI is looking like to begin with. So I think it depends, basically. I think, at least in theory, they do not have to have this, they do not have to be good at conjecture replication in order to help us. But maybe there's some cases where we want.
Yeah, that makes sense. Yeah.
Sorry,
Yeah.
rather satisfying.
But I think it's true, yeah. All right, last chance for questions. Anyone? In which case, I guess put our hands together for Rio again. Thank you very much.